Welcome. In the name of Pampa Energia, thanks everybody for joining us today, mainly from Argentina and South America, but also from many other countries around the globe, such as United States, United Kingdom, France, Spain, Nigeria, Netherlands, and Saudi Arabia. This is a hybrid webinar in person at Pampa Energia's auditorium in Buenos Aires City, equipped to support Teams meetings and virtual through Teams meeting platform. Apologize to our great Hispanic audience, but this is the reason why also the introduction will be in English, besides the lecture. Nonetheless, we found useful, mainly for our major part of Latin American audience members, a recent Teams meeting connection feature to use online subtitles even in the language of your preference. To achieve this, please be patient with this brief hint so those interested can try this latest characteristic. On your desktop's Team Meetings platform connection, in the More Options display, in the three dots at the right top corner, click Language and Speech, and then turn live captions or subtitles on, as you may see in the image screen right now. It is important not to set spoken language always in English, US, because it's the language of the meeting. If not in English, subtitles are not going to function okay. Also, this selection of spoken language affects everyone. Once you've activated the subtitles in your desktop's Teams platform, you can choose the language you want your live captions translated to. By default, they are going to be in English as the spoken language. At the right bottom meetings caption corner, select the More Options display in the three dots, then click Caption or Subtitle, and select the language you prefer. This only affects yourself. Besides, online subtitles can be activated in mobile or tablet Teams connection platforms, as is the case of this auditorium. But in these devices, the subtitles are only allowed till now in the spoken language of the meeting again. Again, the spoken language must be in English, US, to function properly. Perhaps you have to exit and enter to the meeting again to achieve this in case you have language spoken settled in another language rather than English. In the chat of the webinar, you can see a link in case you have any trouble to set live captions translation. As a warning, perhaps the online subtitles are not yet faultless enough, but in any case, we hope they could help and be an example of one of the many tasks that artificial intelligence can currently perform as a mere indicator of the near potential future. My name is Juan Pablo Barrer, and as Omar Seroy regretfully couldn't be here today, I was proposed to coordinate this meeting venue on behalf of Pampa Energia. Hope you enjoyed this event, and for those who could come in person, also expect you like the catering that Pampa Energia will generously offer at the end of this lecture. For this purpose, special thanks to Pampa Energia Public Relations Manager Ines Sainz, and to the great collaboration Marcela Russo, and to Marcelo Ramirez Juan Diaz, extendable to other people involved from Pampa Energia for the venue, lunch, and for the auditorium's online meeting platform assistance, among many others. We especially thank the Society of Petroleum Evaluation Engineers, SPE in advance, who through its chairman of the Latin American chapter, Germán Moss, and others, gently proposed this attractive lecture. Likewise, our profound gratitude to the Society of Petroleum Engineers, SPE in advance, who through its program chairperson of the Argentine section, Fernando Tuero, and others generously organized this event. As myself, as the latest ex-SPE program chairperson, I am pleased to cooperate and to have proposed to the SPE's Argentine section to join this event, with the previously consent from the SPE as the initial organizer, being in this way the first webinar executed in Argentina jointly by the recently mentioned two international well-known recognized petroleum societies. And of course, our immense gratitude to today's lecturer that we have the luxury of having in person in Pampa Energía's auditorium, Zach Warren. Right away, I leave you with Fernando Tuero, Argentine's SPE current program chairperson. Please go ahead, Fernando.
Okay. Welcome to the audience and thanks for
your mic. You have to turn it on.
First of all, this will be green. So welcome everyone. Thanks for being here, and thanks Zach for being here. It's an honor to have this kind of technical executive here. And just to tell you, this conference promotes the SPE mission to collect, disseminate, and exchange technical knowledge, as well as to provide opportunities for professionals to improve their technical skills. So we also thank the sponsors of all these cycles of conferences on the Argentinian section of the SPE, like Shell, Pan American, Energy, Pampa Energía, YPF, Energy, Total Energies, Tecpetrol, Chevron, ExxonMobil, Plus Petrol, Equinor, US Ceramics, Pecom, San Antonio, e Industrias Seco. So in the coming days, you will receive an email with the link to the access of the presentations of today's lecture in the website of the Argentinian section on the SPE. And right away, I leave you with Germán Moss, chairman of the Latin American chapter of the SPE, who will be our prestigious moderator today. So please, Germán, proceed.
Okay, thank you. Thank you, Fernando. Thank you, Juan Pablo. Thank you, Zach, for being here.
Grita, no se escucha.
Sharing your screen. Drop the call. Sharing. Okay. Just a couple of slides.
You're sharing the, you must share the presentation.
Okay. Not sharing. Entire screen.
Entire screen, claro.
Okay.
Yeah.
We're ready. So, just a bit of information and a brief overview, history, and mission statement of the SPE. The SPE was formed in 1962 to answer the need for a professional organization to bring together the specialists in petroleum evaluation engineering. It's dedicated to the promotion of the profession of petroleum evaluation engineering by promoting education of our members and by educating and by education of the public in the area of oil and gas reserves definitions, reserves evaluations, and fair market value. Since its origin, the standardization of oil and gas reserve definition has been a principal goal of the society. In 1987, the SPE, in cooperation with other industry groups, formulated and published definitions which were promulgated jointly by the SPE and by the SPE. The SPE Reserves Definition Committee continues to work with the SPE on potential revisions on reserves definitions. In 2007, the SPE co-sponsor, along with the SPE, the APG, and the World Petroleum Council, the Petroleum Resources Management System. Later on 2018, under the co-sponsorship of the SPE and the SPE, the PRMS was updated. The society also participates in the CO2 Storage Resources Management System Committee, which establishes technically based storage and resources evaluation standards. As all professional organizations in our industry, the SPE also has chapters worldwide, and these chapters' activities complements the society's continuing education programs. Local meetings like these ones provide an excellent forum for the exchange of technical and business information. This slide shows our international 2023 officers and directors, which are elected every 3 years. We also have here our 2023 chapter officers. Check out that we have worldwide 12 chapters, 3 of them out of the US. The Latin America chapter was the latest one established in 2021. After a big effort, we all started in 2019 to gather together professionals and members from the Latin American region. We were successful to finally establish the chapter in 2021. The officers of these chapters are myself, Rafael Cabero, Oscar Balbuena, and Ernesto Duran. Right now we are 13 members. There are actually two members application in the process application, and we hope that we can continue growing in the next coming years. Some publications and resources from the SPE, the survey of economic parameters used in property evaluation. This survey is conducted annually by the SPE to obtain opinions from the evaluation community on certain economic parameters which are used to evaluate properties. Monograph 3 and Monograph 4, which are guidelines and methodologies used in the reserves, in the evaluation of developed and undeveloped reserves in resources plays and unconventional reservoirs. Monograph 5, which is actually not yet published, but is coming soon, which will be a practical guide to type well profiles. And we also have some recommended evaluation practices, which are basically short position papers on petroleum evaluation issues, which can be downloaded for free from our webpage. We also have our annual meeting, which is right around the corner. It's coming soon, in mid-June, in Newport, Rhode Island. It has an exciting agenda of short courses, which includes Power BI applications, Monograph 5 updates, and SEC perspective, and also some technical talks on relevant issues from the industry. I encourage you to take a look at the agenda and register online if you have the chance. Finally, to talk about membership. As you know, this society doesn't have a lot of members. We encourage people who qualify to try to get informed. We can answer questions after today's presentation during lunch. But basically, we are probably less than 500 members worldwide. And the requirements to get registered are basically a bachelor's or an advanced degree in engineering or geology, have at least 10 years of active experience in evaluation of oil and gas properties, and get the sponsor from 3 active society members. Okay, so I would be glad if anyone has any kind of concern or question after today's lecture to give some feedback. So that's all I have from the SPE. Now, moving forward with today's lecture, I will give the biography of today's lecturer. Zach Warren is a data analytics leader and reservoir engineer with over 18 years of experience. In 2021, he founded Velocity Insight to be a full-stack, full-function data management analytics consulting firm focused on upstream oil and gas. Most recently, he was Director of Strategic Studies and Analytics of Great Western Petroleum, leading data analytics and reservoir characterization efforts. He started his career at ExxonMobil with additional experience at Netherlands Fuel and Associates and various light oil operators. Zach is a professional engineer in Texas and Colorado, a member of the SPE, and serves on the board of directors for the Society of Petroleum Evaluation Engineers International. During today's lunch, I encourage you to ask him about his 300 horsepower station wagon. The abstract of this webinar, entitled Fitting Square Pegs into Square Holes, Data Analytics Trends in Reserves Evaluation, talks about oil and gas applications for artificial intelligence, machine learning, big data, and the rest gets louder by the year. Where is the value coming from? How do reserves and reservoir engineering fit in? This presentation will focus on promising areas of analytics for reserves and evaluation work, how they integrate with other upstream disciplines, and real-world barriers to adoption. It's a huge pleasure to be today's moderator. The duration of this presentation is estimated in 1 hour, including the Q&A section. Questions can be made at the end of the presentation during the Q&A section by raising your hand for those here in the auditorium, for those attending virtually, by writing in the chat the question. I will pass them to Zach. And as we mentioned before, in the next coming days, you will receive an email with a link to the access to the video and the presentation of today's lecture. Now I leave you with Zach. Zach, please. Proceed.
All right, hopefully the microphone is working. Does that sound good? That must mean it works online as well. Let me share my screen. Before I begin, I am lucky to be the first one here in Buenos Aires since the chapter was formally certified. The first member of the SPE Board of Directors to be here since then. So I'm very pleased to present a certificate to certify the formation of the Latin American chapter for the Society of Petroleum Evaluation Engineers. The 10 founding members of the society are listed here on this certificate, and I'll present this to Herman and the local chapter. The SPW, yeah, I might be muted. I'm muted on my microphone here, but I'm using the room microphone. So if people on, it's okay, they can hear me, good. So the Society of Petroleum Evaluation Engineers really started as a US-based organization, but always from the beginning knew that it should be an international organization. And over the last 20 years, with the founding of the London-based Europe chapter, as well as the Asia-Pacific chapter, and now the Latin America chapter, that's really becoming true. So I'm excited to see the future of the oil and gas industry in Latin America. We had an excellent conversation about that last night with a fine Malbec and some delicious beef. So I'm excited about seeing that grow over time. Okay, my presentation topic is data analytics. That's what I spend my time on as a professional today, but I started my career doing reservoir simulation at ExxonMobil, working a series of conventional assets around the world. I then went to work for Netherlands Sewell and Associates doing third-party reserves evaluation, and then have spent the last 10 years working in Denver, Colorado for onshore North American assets in Wyoming and Colorado and Oklahoma and North Dakota and Texas. So that's my background. I'm a reservoir engineer. I love reservoir characterization. I've spent too many hours doing decline curve analysis, way too many hours doing decline curve analysis. So my perspective is of somebody from that point of view. However, I also spend a lot of time in other disciplines of not just petroleum engineering, but accounting and midstream and those things. So we'll talk some about not only the opportunities in reserves and reservoir evaluation, but also in the other functions that. Okay. The title of my talk is a little bit of a joke, fitting square pegs into square holes. Of course, square pegs should fit into square holes. And the reason I call the talk that is because data analytics and reservoir reserves evaluation should fit together. They should fit together. And for decades, they usually have. There's some times where they have not. And I think that learning from the situations historically where data analytics and reserves haven't fit all that well together can help us understand what the future is likely to be, where the areas are for the most opportunity and the most potential benefit for us as professionals and for the industry as a whole. So I'll start by talking about some frameworks, some ways of thinking about data analytics and reserves and reservoir engineering, talk about how they have interacted historically, spend some time really digging into what the market for these kinds of approaches looks like today, what software is being used, by whom, and in what ways, and then some things that I'm excited about in the future, as well as barriers to potentially achieving some of those opportunities. I will say, although I am a member of the board of directors for the SPEE, these opinions are mine and mine alone. They don't reflect the SPEE, any of my former employees, or even my wife. She's never seen this presentation. She doesn't care what's in these contents, and she certainly doesn't approve what I'm about to say. So frameworks. If you look at our website, you'll see that I write very nerdy blog posts, extremely nerdy blog posts about oil and gas and data and how they relate to each other. So the next few slides are me distilling those blog posts down to sort of one slide each. If you're interested in any of these topics, you can read more about them. The first is that oil and gas data is really different from a lot of other industries. And I think it's different in ways that are rational, that make sense. I think there are good reasons for the digital transformation in the oil and gas industry to be both dampened, softer, slower, not as fast as in other industries, as well as just different in how that happens. And there's three big reasons. The first is geospatial complexity. In most industries, we care about the two dimensions on the surface, right? I have a Starbucks over here and I have another Starbucks over here, and they compete for customers in a two-dimensional sense. But in oil and gas, we have a third dimension, right? We have depth. What zones are shallow, what zones are deep, which wells have penetrated all of those versus just some of those. That third dimension is not common in other industries. We see it in aviation, we see it a little bit in subsurface mining, but oil and gas is really unique in how important that third dimension is to us. Second, diverse data sets. Just within petroleum engineering, we have reservoir engineers, facility engineers, drilling engineers, completion engineers, production engineers. We have geologists, geophysicists, petrophysicists, we have accountants, we have midstream professionals, landmen. There's so many different functions that are required to make an oil and gas company effective. Each of those functions, each discipline tends to have their own piece of software, their own thing that they use to make their job more efficient. And those different pieces of software don't usually talk very well to each other. So it's important for us to recognize that that diversity of data sets is actually an obstacle. It makes it more difficult to get things done with technology in an oil and gas company. And the third is what I call well-founded risk aversion. I say it's well-founded because it's reasonable to be risk averse if I'm drilling a $50 million well in a mountainous area of South America, or if I'm transporting oil across the ocean in a tanker and I want to be sure that I don't have a leak. Our business can be dangerous, and it's important for our professionals and our executives to have an appropriate degree of risk aversion. What happens in the digital technology space is the risks for what we do is, as engineers with spreadsheets and databases, those risks are not nearly as high, right? An expensive piece of software might cost $50,000 or $100,000 versus $50 million to drill that expensive well. Our stakes are lower doing digital projects, but culturally, we've all been trained, don't have a sidetrack, don't have a spill, make sure that nobody gets hurt. And we take that risk aversion and bring it into projects that really the downside is not that bad. And so it's important to say that risk aversion is appropriate in most areas of our business, but when we're trying to implement a piece of software or do some analytics approach, often the risks are not that high, and we should think differently about it. The second very nerdy blog post I want to talk about is what I call the data pyramid. This is the idea that we have a pyramid of effort required for oil and gas data analysis. And at the bottom is data gathering. That's the widest part of the pyramid. That's the biggest piece of work. I've got to go gather data on which well produced what and what were my PVT properties and my core analysis and how much did I spend. On top of that is data management. That's making sure that the right person has the right data at the right time. I can only do data management if I gathered the data in the first place. And so it sits on top of a foundation. Above that is what I call descriptive analytics. And by descriptive analytics, I mean, how much did I produce yesterday? That in most companies, that is a very difficult question to ask. I don't know if that's the case in South America, but I can tell you in the United States onshore, answering accurately how much you produced yesterday is hard because so much data has to be gathered and managed to calculate that number, right? It's higher up on the pyramid. Similarly, how much money did I spend last month? Well, I probably don't have invoices yet from all of my vendors. I don't know how much money I spent last month. It's very difficult to know those questions, but that's what we try to do with descriptive analytics. Only if I've done a good job of all of those layers of the pyramid do I have any hope of succeeding with AI and machine learning and all of the fancy techniques that people are excited about today. It's all garbage in, garbage out. This is an American saying. I don't know if it translates here, but if I cook a dinner with lousy food, I'm probably not going to enjoy what I eat on the other side, right? Garbage in, garbage out is the nature of all advanced approaches. If I'm doing reservoir simulation or rate transient analysis, it's the same problem. If I use garbage data to try to do AI and machine learning, I'm going to end up with garbage results. It's not exciting and it doesn't sell very well, but the real work of doing this kind of stuff is on the bottom half of the pyramid. That's the pain, that's the suffering, and that's what you have to have spent time on before you're going to have any chance of success at the top. The third, not nerdy blog post is what I call the big six. So for most oil and gas companies, there are 6 pieces of software that are really central to how they do their job. I've listed them here, and you see that on this diagram, I put the ERP, the Enterprise Resource Planning System, at the center. That's your accounting system. If it's SAP or Quorum or any of a number of other pieces of software that are used in accounting. As a reservoir engineer, this is kind of painful to say, but we are not the center of the universe. The accountants are the center of the universe. How much money you spent and how much money you earned in revenue, that's what drives an oil and gas company, certainly in capitalistic societies, which most of us are in. So that is the true heart of an E&P company. The reason I have these listed as the big 6 is because these are the ones that are most highly integrated with each other. Data needs to move between these systems rapidly and efficiently and accurately. Second, they're very central to the basic functions of what an E&P company does. And third, they are extremely expensive to rip out and replace. If I want to replace one of these pieces of software, it's going to cost me a lot of money. It's going to take a lot of time. So I have to be very thoughtful about what I've selected for these pieces of software and how well I've implemented them in the way that I use them in my company. So you see reserves and planning in the top middle. That's what I use mostly as a reservoir engineer. Well lifecycle would be a system like WellView or Open Wells that you might be familiar with that tracks the history of a well as it gets drilled and produces. Production allocation is, let's say my field produces 10,000 barrels a day. I need to allocate that production down to individual wells using measurement and well tests and things like that. SCADA, the way that we collect data from systems out in the field, is becoming more and more common onshore. It used to be something that was only used in very expensive assets, and now it's gotten cheaper and cheaper and is being used in more and more places. And then one system that's a little bit unique to North America, specifically US and Canada, is a land or lease data management system. This is most important when minerals are privately owned. So in the United States, any individual can own minerals, and so we end up with very complex data sets that describe who owns what. This also exists in other countries, but it's so central to what happens in the US and Canada that it's a part of the big 6. So in some jurisdictions, the big 5 may be a better way of understanding that. Okay, let's talk a little bit about the past. Those who don't learn to the past, you know how this finishes, right, are doomed to repeat it. So we're going to make sure that we know a little bit about what has happened in the past. What's old is new again. We're talking about data analytics and reserves and reservoir engineering, but people have been doing this for a long, long time. And the idea of trying to improve what we do in this way is something that people have been working on for decades. And a few examples of what I would consider to be successes in this area. Reservoir characterization. We have subscription data sets available in most countries now for production data, log data, the location of all of the wells. Those subscription data sets now are cheaper and cheaper. They're easier and easier to access. There's a subscription service in the US where you can get all of the well data in the entire United States for $2,000 a month, which is insane. That is a crazy amount of data for not very much money. Neural networks for petrophysics. The first time that anybody published on this concept was in the 1970s. 50 years ago, people were already thinking about using things like neural networks. We've had successes and failures since then, but this is a very old idea. This is not new. For reserves evaluation, computer software for decline curve analysis and economic evaluation has been around for a long time. The first version of Aries, which is a very common software used in the United States, it came out in 1978. I was born in 1979, so it's older than me. And it's still used by thousands of engineers. Reserves management systems for things like EIA and smog reporting for reserves reconciliation. Those are requirements in the United States. Those systems have been around for decades. And then for asset valuation, we have surveys and databases like the SPE parameter survey we mentioned. Black-Scholes option pricing is a great way to handle the fact that we don't know what the future price of oil is going to be. So you can load a distribution of potential future prices into a model and have it come back with an option-based pricing. We usually don't use that for deterministic reserves valuation, but those kinds of approaches have been around for a long time. Now I'll talk about something I call the software proliferation landscape. There is an insane amount of software available for sale targeting oil and gas companies, and a lot of it has been around for a long time. So I've got some logos on here of things that you may recognize. Again, Aries came out in the late 70s, OGSys, Inertia, Integra, Wolfpack. There were a lot of pieces of software that came out in the late 1980s and the early 1990s. And it's interesting historically, a lot of the people who founded those companies were laid off from oil and gas companies in 1984 and 1985 as the downturn happened. They got laid off and they said, well, what else am I going to do? I guess I'll go start a software company trying to make life easier for oil and gas companies. So there was this explosion of new technology that came out in the late 80s and early 90s as companies were formed. And we were also in the midst of the personal computing revolution. And so it became easier and easier to put software into people's hands. And then there's this drought. There's a few logos on here, but if you look at it historically, very little software came out in the late 90s or the early 2000s. There wasn't that supply of people getting laid off from oil and gas companies, and so there weren't all these new companies being founded. There was a lot less innovation that happened. And then starting in 2014, when the price crash happened, remember the Thanksgiving surprise when all of a sudden the price crashed in November of 2014. In the wake of that, another wave of new software companies have come onto the market as a new group of people got laid off from oil and gas companies and said, what the heck else am I going to do? I'm going to go start a company to try to solve problems. So we see these waves of innovation that come and go depending on what's happening in the employment market. But in the big picture, usability has gotten better and better and better. And the cost of these tools has gotten lower and lower and lower. The ability for a small, lean company to use technology to make their work more efficient is better than it has ever been before. And I'm a technology optimist. I believe it's going to continue to get better as we go forward. So we keep a database of all of the pieces of software available for sale that we hear about. At my company, it's got 361 pieces of software in it today. And I find out about probably 1 or 2 or 3 new pieces of software per week that I had not previously heard of. I'm confident the number is north of 500 and it might be closer to 1,000. It is overwhelming how much software is available for sale in this space. And it is a barrier to being able to innovate, because you need to go research all the things that are available in order to figure out what makes sense for your company. So to help with that, we put together a software survey. We're trying to do it annually, but we missed last year because I got busy doing work for clients. But I'll summarize some of those results, particularly for reserves and planning. We interviewed about 100 companies and talked to them about what they use. And there's 3 big themes that came out of it. Number 1 is compartmentalization. The software market for oil and gas is extremely compartmentalized by region, by size of company, by the business model of the company. There are cultural things that are just weird in the way that this group of companies all uses software A and this group of companies uses software B, and they don't even know about each other. They're very isolated in many ways. We see that internally within the United States. I think it's even worse when you look at it internationally. The software that's used in Argentina is very different from the software that's used in the United States. Second, a long tail. There are hundreds and hundreds of pieces of software on the market that barely anybody uses. They have very small market shares. 5% of the total users might use something, or even 1% or less, yet it is still available for sale. And the third is widespread dissatisfaction. A lot of times when I ask somebody, hey, what do you use for that kind of software? The response I hear is, well, I really hate it, but I use X. I think that's a very common theme, that although we use software, a lot of times we're grouchy about it. We don't like what it is that we're using. And we also heard a lot of barriers to modernization. Number 1, it's expensive to change. It's painful to change. It's often not very fun. And it can slow down how quickly you can get your job done for a while. Number 2, especially in North America, I think this is true overseas to some extent, but in North America, our companies are constantly being bought and sold and going through mergers, and those kinds of changes always feel like they're about to happen. And so it's difficult to make a software decision that may not pay off for 2 or 3 years when you're, oh my gosh, we might go bankrupt next year. I can't make a big long-term choice like that. Third, we talked earlier about well-founded risk aversion. I think in some cases there's risk aversion in software implementations that is not well-founded, that is inappropriate, but culturally we need to be risk averse because we do dangerous things, and we take that into oil and gas technology in a way that's not always appropriate. And the fourth that I hear a lot, and I think is sometimes true, is that there sometimes aren't better options. We may already be using the best available piece of software, even though we're dissatisfied with it and wish that it were better. There's nothing better available to purchase. So some summary statistics. The slides will get distributed afterwards if you want to look at this closely. But again, we had about 100 participants. They range from very small companies to super majors. The survey covered about 65% of the US listed public E&Ps. It is very North America focused, and within that, it's very Colorado focused because that's where I live. That's where a lot of my network is. But it does cover a total of about 500 total software implementations, which represents several $100 million of annual software spend. And you can see on the bottom here that a distribution of which piece of software is used most often. Aries comes up most often. WellView is number 2. Merrick, which is a production allocation system, is number 3. And then we get into that longer and longer tail of pieces of software that are used by a very small number of companies. So this survey covers the big 6 categories, and one of those is reserves and planning. In the United States, Aries really dominates. You can see out of 126 implementations in our data set, 65 of them are Aries. It's used by 2/3 roughly of US oil and gas companies. However, it has a lot of limitations. And so there's a lot of companies that use other things in combination with Aries or with PhDWin or with ValNav or one of those. They might use InterSight for better rig scheduling. They might use Combo Curve as a rapid evaluation tool. They might use a Spotfire template or something like that to deal with the limitations of a lot of these pieces of software. So among my friends, almost everybody uses Aries and something else, PhDWin and something else, ValNav and something else. It's a very, very common situation in this area. That's not necessarily true of the other areas of the big 6, where usually one piece of software can solve all the problems. That's not true in reserves and planning. Here's another data set. This is published by SPE in 2018. It shows PhD win as being above Aries, but the sample set is different. So my sample set is entirely E&P companies, whereas this data set includes a lot of people who work for consulting firms and other organizations like banks and academia. I think both of these data sets are true and accurate, but they have different populations. Aries is much more dominant in the E&P space. PhD win is used a lot more commonly in consulting. PhD win is more commonly used by smaller companies, where Aries is more common in larger companies. ValNav and Mosaic are more popular in Canada and outside of North America, while they have relatively low market share in the US. Again, speaking to the regionality, the compartmentalization of this market. Again, those slides will be distributed so you can zoom in and look more closely. Another thing to be aware of in the current state of what's happening in this area is that this software is being bought and sold all the time. This is often invisible to the user because the logo on the piece of software doesn't change, but Mosaic went from Intero to Quorum and then got sold to Omnira. ValNav went from Energy Navigator to Alcerna to Quorum. Intersight went from Intersight to Acerna to Quorum. Petrolook from Aclaro to Acerna to Quorum. You might be hearing a theme that Quorum's been involved in a lot of these. PEEP, this is a huge deal that almost nobody seems to have talked about enough. PEEP is an extremely popular piece of software internationally. Went from Schlumberger to Quorum. That is a shocking change in my mind. Combo Curve, which is, I've mentioned before, that's a relatively new piece of software. They raised $50 million in funding via their Series A and Series B financing rounds in the last couple of years, which is a lot of money to develop software. That is a lot of money to hire programmers. So there's an enormous amount of change that's happening in this area. And a lot of these legacy tools are going through very big changes. So PhD Win went to version 3, which is backed by SQL Server instead of their old database. Aries version 6 came out. They finally have 64-bit capabilities, which was kind of a decade in the making. It took them longer to release that than I think they wanted to, or than anybody wanted to. And they now have a daily calculation engine instead of just monthly. That's a huge change for Aries users. And then with Quorum now owning ValNav, Intersight, Petrolook, PEEP, and Planning Space, what are they going to do with all those? Are they going to merge them all together? Are they just going to create integrations? Are there one or two of these pieces of software that they're really going to focus on and leave the rest languishing? This is a fascinating space. It changes at least annually and often monthly in terms of what's happening with ownership of these tools and new developments that are coming out. So time for a quiz. I usually take this quiz in North America, but I've repurposed this for Latin America. What is the total addressable market for E&P reserves and planning software in Latin America? I have some ideas about what this number is in the United States, but total addressable market means the annual total revenue, right? In all of Latin America. So think about it. How much do you spend at your company for your software licenses? Okay, about how many companies my size are there in Latin America, and start to sort of guess at how big you think this total pool of money might be. And I'll give you 4 choices, and you're required to vote. You're not allowed to stay silent. So do you think it is A, less than 10 million, B, 10 to 25 million a year, C, 25 to 100, or D, over $100 million a year? Think about it a little bit. You can vote online. You can type in A, B, C, or D and see what it is. But for those of us in the room, is everybody ready? You've thought about it? Thought about it? All right. Everybody who thinks it's A, raise your hand. 1. We've got 1. Okay. Everybody who thinks it's B, raise your hand. We've got a bunch of Bs. Okay. Everybody who thinks it's C, come on. Okay. We're good. Anybody who thinks it's D, greater than 100 million a year? Ah, the old guys in the front, they think that it's a lot of money. It's a really important question. If you understand how much revenue this is, it can help you understand, like, how big is this space, and how much should I expect in terms of the software company's ability to innovate? If you think it's a low number on here, that means they don't have very much of revenue available to go hire software developers to improve their tools. If you think it's a higher number, they have a lot of revenue available to go hire software developers to build new tools. I have no idea what the answer is. There may be a software company that's done enough work that they think they know what the answer is. Because almost all these companies are privately held. There's no public data on this, but it is an incredibly important question. How much revenue actually goes to these software companies. Okay, those who don't know the past, we know a little bit more about the past and the present now. Maybe not everything, but a little bit more. We want to be sure that we're not doomed to repeat it, that we only repeat it when we want to. So let's talk about the future. So I like to think in terms of, there's a common saying in the US, cheap, fast, and good. You get 2 of the 3. Is that a phrase that you guys have heard before? Cheap, fast, and good. You get 2 of the 3. So let's talk about cheaper, faster, and better. So if you're trying to use data analytics as a value driver, not just like a fun thing that you talk about, but something that actually makes a difference for your business, to get things cheaper, right? To do your analysis cheaper and develop your wells, I think it's most important to focus on the bottom of that data pyramid. Focus on data gathering, focus on data management, because you have a lot of people in your organization that spend a lot of time on that today. And if you can make their day-to-day work more productive as you gather data and bring it into the corporate headquarters to do the forecasting, your business will run more efficiently. You will be a cheaper running business in the long term. You'll spend less money. I also think in terms of automating data processing, right? I've gathered SCADA data from all of my gas meters and all of my tank levels and all of my pipelines. I bring that into a central system and then I allocate production out to individual wells. That should be automated. That should not be getting done in a spreadsheet. That should be done using a piece of software that runs overnight on its own. That should not require manual input. It usually does. And if you're looking for an opportunity for how to make your business run more cost effectively, automating data processing is a great approach. How do you get your business to run faster, just to move faster? I think as a reservoir engineer, one thing that I've struggled with a lot in my career is getting access to good accounting data. I talked earlier about how accounting is the true heart of an E&P company, and even though it's kind of painful for me to admit it, but getting better access to accounting data like operating expenses, differentials against the index pricing, capital expenditures, getting better access to that as a reservoir engineer, as a production engineer, as anybody in the organization will make your business make decisions more quickly and more efficiently, right? If I can tell which one of my wells is making the most money and which one of my wells is losing the most money, it's so much easier for me to make high quality, rapid decisions. Another area that I think is really exciting for accelerating the pace of our businesses, especially for unconventional reservoirs, is automated decline curve analysis. I don't think you can just leave it to a machine. I think a human needs to be involved, but at least getting a first pass evaluation or looking for when the existing decline curve is most likely to need to be updated. These approaches are, I think, are getting really mature and have gotten to the point where they should be getting used by most companies. And finally, better. I think that when we think about using data analytics for oil and gas, the biggest opportunity is to reduce bias. How many people are reservoir reserves engineers? Is that most of the room? Half of the room? As a reservoir engineer, I know that if I had a lot of coffee and I got a good night's sleep, I tend to do my decline curve analysis a little bit differently than if I have not had enough coffee and I'm a little bit grouchy and I got in a fight with my kids that morning, right? My mood affects the way that I do forecasting. It's good to admit that. And data analytics approaches can help us reduce, not remove, but reduce the amount of bias that we have in our forecasts. Improving run QC to minimize errors. When I do a reserves run, I have 100,000 assumptions that go into the software that determines my reserves. And it's very easy to have made an accidental mistake. I fat fingered a number when I inputted it into the system, or something's out of date and I forgot to update it. So doing automated data quality work can really improve the quality of the evaluations that we do. And then I think an area that's really interesting is when I'm doing type well profiles, also known as type curves, I want to bin wells into different categories, right? 1,000 meter wells and 2,000 meter wells in terms of lateral length, or big frac jobs and small frac jobs. There are some algorithms out there and some approaches that can do a really good job of helping us identify factors that we may not have guessed about as being important. This is kind of an older example, but for a long time in North Dakota, in the Bakken, there was a recognition that the size of your frac mattered, that bigger fracs were better than smaller fracs. And for a long time, everybody did that evaluation based on how many pounds of proppant or tons of sand, right, that we put into the ground. That was the metric that people used. But we were doing an evaluation at a previous company of mine, and we started to realize that actually it wasn't how much sand we pumped that mattered most, it was how much water we pumped. And that if we pumped a larger volume of water, that was more helpful than pumping a larger volume of sand. That was something that came out of a random forest algorithm. In hindsight, it seems obvious, and I think in a lot of basins that has now been proven to be true. But at the time, this is like 2011, 2012, it was an extremely surprising conclusion. We were not expecting that at all, but that's what came. We weren't seeing with just our human eyes. So AI and machine learning, what are the things that we should be focusing on and excited about? I talked about automated decline curve analysis. I think this area is really starting to mature. Some of the systems out there now are doing a good job of taking the full history of a well and cutting them into separate chunks. So maybe I have an initial decline period and then the well loads up and dies and I put it on artificial lift and I get a bump and it's got a new character for a little while. And then maybe it gets fracked into by child wells and that changes the character of it again. A lot of these algorithms are now able to identify those different periods of time and recognize that the old data is no longer relevant, right? We fracked into this well and it's never going to look the same. And it will only use the most recent period for the automatic decline curve analysis. There's a lot of controls out there for constraining the range of B factors or the final decline. A lot of these techniques are so much more sophisticated than they were even 5 years ago. That said, I do think that a human probably will always need to be in the loop. If you're going to submit something as this is the reserves, these are the reserves for this company, I think you're always going to want to have a human doing a degree of review on that work. Next, type well profile creation. I really think this area is making a lot of progress. Clustering algorithms are a way of looking at a large data set and saying, without human intervention, what are 10 categories of wells that are most similar to each other? These are unsupervised techniques that don't require a human in the loop that will sometimes show you trends that you would not have guessed. They can be very, very powerful. They're also efficient. They can make you they can help you get your job done more quickly. Has anybody heard the term R-squared loss? This is a really, really good technique for recognizing which of the input parameters for a type well profile is most important. So for instance, if I'm in the Vaca Muerta and I've got different lateral lengths and different frac sizes and different well spacing and there's different landing zones, I believe, right? I can put all of those into an algorithm and say, use all of that data to try to predict the 12-month cumulative oil production, right? So if I do all of that and let's say I get an R-squared of 0.7, which would be a pretty good correlation in our business, right? Now remove one of the variables, remove the lateral length and see how much R-squared I lose. Now put the lateral length back in and remove the frac size and see how much R-squared I lose and do the same with all the other variables. And then you can rank all of the variables by R-squared loss. That's a great way of understanding which of the variables are most important, most relevant for predicting cumulative oil production. It's very explainable, right? I just explained it in 15 seconds. I see some heads nodding. I think some people understand that. And so it's a good technique for taking what is an extremely complex analysis and explaining it to other people in your organization in a way that they're likely to understand what it is you just talked about. And the third thing for me is data quality, data quality, data quality. If you have not spent time making sure that your data is accurate, you should not spend time on AI and machine learning. There are actually some techniques now to use AI and machine learning to help you with your data quality. But if you have not verified that the data you're working with is accurate, don't waste your time. Spend your time making sure that your data is reasonably accurate before you move forward. Some questions for adoption. I think in the United States, we're very focused on SEC regulations, and they have this phrase that only reliable technologies can be used in the calculation of proved reserves. So what are reliable technologies in this area? The SEC has said the decline curve analysis using the ARPS equation is a reliable technology. The material balance and reservoir simulation can be reliable technologies. Is a multi-layer neural network, is that a reliable technology? Is a random forest algorithm reliable technology? In some cases, I think that's relatively clear, but in other cases, I think it's uncertain. And that if you're going to rely on a technique like that for reserves bookings, you need to have thought that through and make sure that whoever your regulator is agrees with you that it's a reliable technology. Second, are these techniques transparent enough and explainable enough for all of the stakeholders involved? Not just do the reservoir engineers understand it, but do their bosses understand it? Do their peers understand it? If you're a publicly traded company, do your shareholders understand it? Does your board of directors understand it? Do your regulators or your accounting auditors understand it? If you haven't been able to be transparent and effectively explain what it is you've done, then you're probably not going to have good buy-in. And then finally, I think this is an interesting comparison. How does the signing of a reserves report compare or not compare to the signing of a financial statement? In the United States, chief financial officer, a chief executive officer have to sign that their financial reports are complete and accurate. And inside of a financial statement is an array of different data types. We have invoices and revenue data. We have mark-to-market evaluations, lease liabilities. All these things get stewed into a financial statement. And more, we're using data analytics approaches to calculate some aspects of financial statements. If I'm going to sum up all of the revenue for 2022 for my wells, I'm not going to do that with a calculator. I'm not going to do that manually. I'm going to trust a database to calculate that for me. But there are other parts of a financial statement where a human is going to be intimately involved. The areas where more judgment is required, where more subjective interpretations are coming out of it. I think that's a good analogy for a reserves report. If I'm writing a reserves report, there are some components of what I'm doing that can be automated, that can be trusted to an algorithm of some kind because it's clean and simple. And there are other areas that are probably not good for trusting to an algorithm, that we're going to need to have a lot more human intervention. I have a lot more slides on the backup, but I want to get to questions first. So I'll wrap up here. In my view, none of this is new. This is a continuation that has been going on for as long as I've lived, and frankly, a lot longer. And it's important to think about not just where are we today, but where did we come from in helping to understand where we're potentially going and what areas are going to be most likely to be useful. Focus on the bottom of the data pyramid. I say this all the time, and I just believe it so thoroughly. Focus on your data gathering and your data management before you try to do any of the fancy stuff. If you haven't ensured that you have good data quality, you're probably wasting your time. And then finally, I think especially for reserves work, there are so many stakeholders in reserves and reservoir evaluation, so many people who care about the outcome of the results, that if you have not properly thought about their perspectives and their biases and what ways they might object to what you're doing, if you haven't thought about that, you're really putting yourself at risk, potentially from a career perspective, that your boss is going to be mad at you, but also you may just kind of be wasting your time. If you haven't really thought about that stakeholder perspective, then you need to before you haul off and do a lot of work. So with that, Velocity Insight, we're like you said earlier, we're a consulting firm. We focus entirely on E&Ps. We've got about 13 people on the team now, and have about 24 clients, and we're all from deep inside of oil and gas. If you want to hear more of this kind of thing, we've got a LinkedIn page. We have a newsletter that goes out. I would love, my data set for the software survey is so biased towards North America. I would love to get better understanding of what people use in South America. That would be interesting for me, and I think it would be very useful for people around the world. So if you're interested, please, you can snap that QR code and fill out the survey. Again, that'll be in the materials that get distributed, but please do fill out that information. We will never disclose that data on an individual basis. We always aggregate it before we report it out. So it'll be kept confidential to us. You don't need to worry about that. Thank you for your time. With that, I'll open up for questions.
Yeah, for those here in the auditorium, please raise your hands if you have any questions. For those attending virtually, again, please write down your question in the chat and we will pass it to Zach.
And there's a way of raising your hand digitally as well.
Okay. Yeah.
Just realized I turned off the screen for people in the room without intending to.
Here we have a question. Just.
That's a great question. So the question to summarize for the audience online is, how many wells do you need for a multivariate analysis? I think is your question. So there's actually a way to calculate that. There's a set of equations in statistics called power calculations, which tell you how much statistical power you have in an analysis. And so it's not just how many wells do I need? It's how many wells do I need to calculate a certain difference. So imagine if I'm trying to test two frac designs, and one of them is 1,000 pounds per foot, and the other is 2,000 pounds per foot. That's a big change in frac design, and I would expect that there would be a big change in well result, right? Maybe doubling should improve my wells by 30 or 40%. That would be a large change. That's going to require fewer wells to be statistically sure that the difference is real. However, if I was going from 1,000 pounds a foot to 1,100 pounds per foot, it's a very small difference, right? There's so much noise, there's so much variation in the well results that the number of wells that would be required to tell the difference between those two frac designs is huge. So when you ask a question like that, it's not, oh, I need 5 or I need 50 or I need 500. What are you testing, right? If I'm testing two dramatically different designs, different reservoirs with very different, reservoir properties, different completion designs, different spacing algorithms. If I'm testing something subtle, I'm going to need a lot of wells. If I'm testing something dramatic, I won't need as many wells. Was that a good way of refusing to answer your question? Yeah, there are equations out there. Look for statistical power calculations where you can predict based on the expected distribution. You basically make a guess as to how big of a change you think it's going to be and how much uncertainty there will be in the results. And these statistical power calculations will tell you how many wells you need to have a certain degree of confidence. Good question.
We have a question here in the chat from Federico Dordoni. His question is, there is a lot of visibility for tools at the top of the pyramid, but not much is said for the groundwork needed at the bottom. Are there tools or software that can help with the data mining and organization? QC of that data?
Yeah, there are. There's a number of tools that are both industry generic as well as industry specific. So in the industry generic world, there are tools like Informatica, Orchestra Networks, some of those that are used in a wide range of industries, retail and manufacturing, but can also be used in oil and gas. Some oil and gas specific ones include S&P has a tool called Enterprise Data Management. Quorum has a tool called Energy IQ. There's a consulting firm out of Oklahoma that has a tool called EnerHub. And these are tools for matching data across systems, what they call master data management, as well as data quality. So you can put a rule into the system that says, if my country is listed as Argentina, then my lat long needs to be inside the boundary of Argentina, right? And my total depth in measured depth should always be deeper than my true vertical depth, right? If you're going to have deviations, then your true vertical depth is always going to be shallower than your measured depth, right? So you can build rules like that for data quality into those kinds of platforms. They're expensive. They're very, very effective. For larger companies, I think they're a great choice. A lot of smaller companies will use what I call a data quality dashboard. So with that, you would use a tool like Spotfire or Power BI to show you where your data quality problems are. So we have some examples of that that are in the backup that I can talk about if people are curious. But you would say, instead of putting that into a fancy piece of software, I would just build a report that says, show me all the situations where my PUD got drilled more than 5 years after the born on date, right? That's a rule for SEC reserves that my wells have to be drilled within 5 years. Just show me a list of those that violate that rule. That's a lot cheaper. It's often easier to implement, but is not as robust. So a great question. There are a lot of tools out there that can help with data quality. At the end of the day, data quality relies on professionals who have judgment to write those data quality rules, right? So that it's complicated.
There's a tool called Poseidon that I've used in the past. It's very interesting because it has like 75 flags on your production history and well intervention. For example, sudden changes of workout without any interventions of the well, sudden changes in GOR, interventions that don't appear to be don't appear to have any effect on the production history. It's like 75 flags that you can start. I've never
heard of that. Now I have 362 in my database.
It's the company is called 360. And
360 Poseidon.
And the software is called Poseidon.
I'll have to look it up. Yeah.
It's very it's used much in Asia.
Interesting. Yeah. Cool. Great question.
I have a question, Zach. So what analytic trends do you think are the most overhyped right now? And also, if you can explain a bit more about the difference in data analytics in onshore versus offshore, if you have an opinion on that.
Sure. Yeah, onshore versus offshore, I think is really interesting. In general, we drill cheaper wells onshore, and there's more of them. And so the volume of data that we end up getting is higher. We also tend to have lower quality data onshore because the value of every piece of data doesn't get as much attention. Onshore assets tend to have SCADA systems much more often than onshore assets do. So I think in general, what you see offshore is you have less data that is of higher quality, and onshore we often have more data that is of lower quality. And so when you think about your data pyramid and the amount of work that you have for data gathering and data management, the whole bottom part of the pyramid is often very different. I think from an operations perspective, at least in the United States, offshore assets usually have 24/7 monitoring because there's somebody physically on location on an offshore platform that's in a control room watching what's happening on every well all day and all night. That does not happen in the US onshore. There's very, very few wells that really get 24/7 monitoring. So I think in particular, the bottom half of the pyramids are very, very different between onshore and offshore. Overhyped trends. I'm getting close to the point where the next time I hear somebody say AI, my head's going to explode. Like, people just talk about it so much. And I think that AI today, I don't know what's going to happen in the future about AI, but today, I think that AI is most useful when you have a very specific question with a very large data set available to train it. So an example that I talk about a lot is in the United States, every private mineral owner will have a contract, a lease agreement with the operator. And that lease agreement will have a whole series of terms and conditions in a document. And those documents are often very structured. The order of all the paragraphs in this legal agreement can be very consistent. And there's lots of them. I mean, millions of these agreements that exist as PDFs. And if you're a large operator, you might have 100,000 of these agreements that you can feed into an algorithm and have that algorithm read the document and extract, this person leased the acreage to that person on May 15th, and here's the description. And you can extract that data because you've asked a very specific set of questions on a very large data set, and it does a good job. If we ask questions that are vague on small data sets, it's going to do a terrible job. And so I think with AI in particular, it's very important to have a well-crafted question that you are asking of the system and supply it with a data set that is large enough. It's not, have you seen the movie The Wizard of Oz, right? It's not a magical wizard that can do everything we want. It's a guy behind the curtain who can do a very specific set of things, sometimes extremely well, but it can't do everything at all times. Do we have any more questions from the chat?
I have one more,
Yeah.
Zach. We've discussed this in the backstage, but I think it's nice to share with the audience. It's like, as you mentioned, there are a lot of softwares that most of them are oriented to planning and another mostly to reserve stuff. And what you explained to us is there is not yet a software that has all the integration of the planning and reserve stuff all together. What do you think? Is it possible to have it in the near future? What do you tell us about that?
Not within the next couple of years, I don't think. So for those who are users of Aries or PhD Wind, they're very robust as reserve systems. They're not very effective as planning systems because their rig scheduling and those kinds of tools are not as effective. They also can't really go into reservoir characterization because those tools don't have things like rate transient analysis or material balance or those kinds of tools built into them. So there's a slide that I like to show. I call this the Venn diagram of doom. So this is all the things that a reservoir engineer might need to do in their day, right? They have some decline curve analysis. They need to do some mapping. They need to build type curves and economic modeling and rig scheduling and all those things. And there's a certain set of those things that Aries does well. There's another set of those things that Intersight does well. A third set for a tool like Phuket Harmony or Whitsun or Sahara does a number of these things. But right now, there's not one tool that can cover this whole space very effectively. And you know, as I talk to the software vendors, there are definitely some of the software vendors that want to cover the whole space. I don't think any of them do it today. Some of them are a lot closer to being able to cover it than others. Some of them have more financing available to go do the software development necessary to expand their footprint than others that don't have enough financing to hire enough software developers to go do this. So the bad news as a reservoir engineer is nobody can do this today. I think the opportunity is if reservoir engineers go talk to the software vendors and give them very clear guidance as to why they want a certain set of features and potentially even offer to co-develop, to work together with a software vendor. I know of one software vendor that is very good in reserves and economics and rapid evaluation and those things, but they don't do anything in rate transient analysis. And to me, that's a huge weakness for unconventional assets because I think rate transient analysis is incredibly important to doing high quality evaluations of these reservoirs. But rate transient analysis is something that software vendor just doesn't know anything about. And I don't think they have a good understanding of how important it could be for economic evaluations. If I can do high quality RTA, my economic evaluations are going to be better. And so this is an opportunity for reservoir engineers to go talk to their software vendors and say, here's what I wish you had. And oh, by the way, if you had it, I'd be willing to pay you this much more money per year. There's a financial incentive. We will increase the total addressable market for your software. You will make more money if you build this feature. Sometimes the software vendors don't have confidence that if they built a feature, anybody would buy it. And so that makes them risk averse. So hopefully that's a helpful answer.
Yeah, thank you very much, Zach.
Yeah. I won't name names here, but if you ask me at lunch, I'll name names. Yeah.
Question, well, I'm not sure if it's a question, but I would like to hear your comments. You mentioned that all the stakeholders need to be aware of or all together in the same pool of knowledge in order to better estimate reserves and serve everyone in the company in order to move forward. So I think that sometimes, or I would like to know your opinion about that, the problem is the time of the decisions all the stakeholders need to make. For example, you have a numerical simulation as a tool for example, forecasting a new set of infill wells or a new set of water flooding rules or a different design of water flood. And that may take you 6 months. And the people from the purchase, they need to buy the pipes tomorrow, and they need to start the procurement. People need to do other things. And the people in the field, they need the data daily because they know how, they need to know if they have to, for example, increase the pumping speed or not because they're losing liquid. So as the timings of the different decisions the different stakeholders make are different, how can you compatibilize that with what you said about softwares and reserves estimation?
Yeah, so to me, that has all been really hard when we did everything with physics-based approaches, right? Material balance or reservoir simulation. And adding AI and machine learning to that probably makes it more difficult, not less, right? If it took me a long time to explain to somebody my water flood design that was based on my heterogeneity calculations and my sweep efficiency and all that, if I'm now going to say, oh, I asked ChatGPT what my well spacing should be, and it told me 40 acres, like the degree of trust for that, I think, is going to be very low. It's going to be very difficult to persuade the stakeholders that your answer is reliable. And so there's a lot of people who write about the importance of explainability for AI. And it's not about like select the best possible algorithm and then figure out how to explain it. It's choose algorithms that are going to be explainable by their very nature. If you choose algorithms that are more opaque, you will have a hard time explaining them, and you will have a hard time getting alignment. If you choose algorithms that are transparent, it'll be easier to explain it, and it'll be easier to get alignment. And sometimes that means you might want to do your work in AI and then come back and use decline curve analysis to actually sell the idea, right? Okay. Like you may end up having to solve the problem with multiple methods, knowing that the more complex models are going to be difficult to explain and difficult to get alignment on. Again, I don't think I actually answered your question.
No, it was not a question specific, but just a comment on the problem of the stakeholders and the timing.
I do know of a number of operators in the United States that have now started to do data analytics training for executives. And so they'll introduce concepts like statistical significance and something like R-squared loss and some of those methods to the CEO or the CFO, so that when it comes time to bring a more advanced technique to them, you know, this executive who graduated college 40 years ago and may not be aware of some of these techniques, they're very smart people. They're extremely capable of learning it, but to give them an opportunity to understand some of the state of the art so that when it's time to make a decision based on those techniques, they already have the vocabulary and the frameworks. I think that's a really smart approach.
Sure.
Any other questions from folks here in the audience? Yeah. What do you think that? So much. Companies mm-hmm. I think a lot of it comes, let me repeat the question. Why is there so much regional variation in the use of software, despite the fact that there's big companies, you know, we have Schlumberger and Landmark and these big companies that sell software. In general, big companies do not write new software. Small companies write new software, and then big companies buy them and smash them together as Landmark or Schlumberger or Quorum. Quorum now owns 35 different pieces of software. 35 pieces of software. They natively developed, definitely fewer than 10, I think fewer than 5 of those 35 were natively developed at Quorum. The rest were purchased and merged into one company. So when you think about it from that perspective, that may explain it a little bit more, right? A small company starts with one salesperson And let's say that salesperson lives in Denver. And so they're pretty effective at selling their software to people that are physically in Denver. But Dallas, which is an hour and a half flight away, never even hears about it because that salesperson doesn't live there. They don't go around and talk to people. I think this is part of why Sahara is so infrequently used in the US. I saw a demo of Sahara a while back. And I was like, wow, that's really cool. It'd be very useful in the US. And nobody in the US uses it because of salespeople and because of history and the fact that the people who are advocates for it don't live in Denver or Houston or Pittsburgh or those kinds of cities. So I think that is just structurally permanent. Big companies do not write software in oil and gas. Small companies do. And so small companies start with their initial customers and they build from there. They don't market worldwide until they're at a large company. And by then there's all this momentum and it's like, oh, well, that tool is really used in Latin America. You know, maybe there's translations that need to be done to make it work in Arabic and nobody's going to take the time to translate it into Arabic. Those kinds of obstacles are big. Good question. Yeah. Very good.
Any other question, or we can conclude the Q&A section?
Thank you so much for the invitation. Thank you so much for the time. Thank you for hosting. It's been a pleasure, and my goodness, you have a beautiful city. This is a wonderful place to visit. Thank you all for having me. Oh, very good.
Certificate of recognition.
Excellent. Thank you. Yeah.
Well, thanks. Thank you very much. Thank you, all the people. We have the lunch right here waiting for us, so we can go there.
Very good. Thank you.
The owner of Sahara one time slumbered a person to buy some. My advice is he said to slumbers, my advice is don't buy it because you will still get people only in Argentina using it, even if it's from slumbers. So